All right, so this is going to be the first of the examples that we're going to look at, kind of comparing the pandas and polars libraries. And if you recall, I've got these up in a GitHub repository, so I'm just going to pull up an incognito window very quick. So if you go to GitHub and you go to the search and you do a user colon Freemanalytics, I need to spell it correctly. So let me go back there. User colon Freemanalytics. There we go. All right, so if you go to your repositories, pandas polars comparison, what we're going to be doing is we're going to be looking at this Netflix titles analyses. So if you want to go there, you can find the notebook, and definitely if you want to kind of follow along, you'll want to look at that Netflix title CSV, bring that down. And that was just a data file that I found off of Kaggle. All right, so what I am going to do is I am going to activate a virtual environment I've got called primary. And in this virtual environment, I'm going to look through, and I just want to show you. So what version am I using? So I've got polars here. I'm using that 1.0.0 release, so that recent 1.0 release, and then pandas version 2.2.2. All right. So I'm going to launch Jupyter, and I will bring that over to this side. All right, so I've got a folder called demo on the desktop, and you can see that in that folder, I've got that Netflix title. So I am just going to open up a new Jupyter notebook in that folder. So you can see I've got this untitled notebook, and I'm just going to go ahead and rename that. I'll say, well, this is going to be Netflix. All right, so let's import a few libraries that we're going to use for this analysis. So we are going to use from the standard library pathlib. We will use matplotlib, pyplot. So I'm going to import that as plt. I'm also going to use the ticker module from matplotlib. So that's going to be ticker, and I'm going to import that as mticker. And then we will import pandas as pd and import polars as pl. All right, so just to again show you, so let me go ahead and write some print statements. So I'm going to print out the version for both pandas and polars. So I'll do pd.dunder version equals, and then I'm going to do the same thing for polars. All right, so we're on pandas 2.2.2 and polars 1.0. All right, so let's just take a real quick look at our data. So I'm going to make a data file path, and I'm just going to say, well, that's going to be pathlib.path, and I'm going to point that to that Netflix titles CSV. And then let me just read this in really quickly with pandas. Just print maybe the first 5 rows, because what we're going to do is we're going to define some questions. So in particular, we're going to define 4 questions that we want to answer using this data. And then we're going to use pandas to answer or conduct an analysis that answers the question. And then we'll do the same analysis with polars. All right, so for now, I'm just going to read that data file path and then immediately do head. All right, so you can see with the data, what we have is we've essentially got a data frame here. So this is going to be a pandas data frame of various shows that are on Netflix. So we have a show ID for each one of the shows. We have a type, apparently indicating whether this is a movie or a TV show, title, director, and then we have cast. And this cast is essentially a string where we have individuals separated by a comma, right? So they've kind of lumped all of the cast into one long string separated by a comma. We have some other information, country, the date added, the year a movie was released, and then we have the duration. We have listed in, so these are like categories that apply to a particular show or movie, and then we have a description. All right, so this is kind of what the data looks like as far as a structure. We're really going to be, operating with the show ID, this type. We're going to do some analysis on the cast and these release years and the categories that are contained in that listed in columns. All right, so let me just do that read one more time and get the shape. So we've got 8,807 entries in these 12 columns. All right. So that's what we have. So let's define some questions here. So I'm just going to get a markdown cell and we'll just say we've got some questions. Yeah, that should be fun. And then let's just go ahead and we will list them. All right, so we're going to say Q1 and we're going to say what percent of titles are movies versus TV shows. All right. Question 2, we're going to say, what has been the trend in movie/TV show releases by year? So how has that evolved over time? Are we seeing a trend towards more movies, more TV shows, or is everything kind of looking the same, not really changing? And I'm going to say, who are the 5 cast members associated with the most unique titles? So, and when I say the most, I'm just saying, which are the 5 cast members associated with the largest number of unique titles? And then finally, we will say Q4. Who are the 5 cast members associated with the most unique categories? All right, so those are going to be the 4 questions that we're going to be, so let me change that to who. All right, these are going to be the 4 questions that we're going to go looking, and they kind of, range in complexity, and I kind of chose them with the hope of kind of showing some different, elements of these 2 libraries, so how to perform different operations. So I really kind of want to get a little bit of a diversity and make sure that I'm, kind of giving you a broad sweep of exactly how things will change. All right, so for everything to be nice and concise, I'm just going to recopy that data file path down here. And what we are going to do is we are going to start working on Q1. So let me just make a little heading here and a markdown cell. So we're going to say Q1. All right, so what percent of titles are movies versus TV shows? I'm just going to take a little bit of a note of the time so I can go back and throw in some chapters in the video. All right, so what we want to do in this one, right? So we've got, 8,807 entries in that data, and we basically just want to figure out, what's the percentage of that 8,807 that are movies versus, say, TV shows, or if there's other types of shows that are provided in that data. All right, so let's go ahead and let's do this in pandas, right? So we are going to do a pandas implementation. So let's go ahead and do markdown here, and I'm just going to say this is going to be our pandas implementation. Great. All right, so we've got a CSV file. So the first thing that I'm going to do is I'm going to read in that CSV file, and we have our file path object above. All right, so we're going to read that in, and I'm going to store this in a variable called data. Now, one thing I haven't mentioned, and let me go back and just kind of modify, whenever we're answering these questions, I did notice when I was kind of testing around with this data, there are some, shows that seem to be really old, like 1942 or something like that, but there's not many. So it really kind of picks up in volume after 1990. So as we're going through these, we are going to limit our analyses to titles released during or after 1990. All right, so we're going to limit that analysis. So what we need to do, if we look at our data, right? So I've got data.head here. So our release year is going to allow us to kind of do that filtering. I'm just going to check real quick and look at the type of that, make sure that it is in fact a numeric type. So if I look at our release year, we've got 8,807 non-null values. So we had 8,807 entries. So basically we've got complete data in that column, and it is an integer. So it's a 64-bit integer. So what we can do is I can make a filter and say, okay, well, give me back a Boolean series where release year is going to be greater than or equal to 1990. And I'm going to call this my year filter. All right. So what we get back here is now we've got a series of trues and falses, which are capturing whether or not a particular title in a particular row of that data frame was released during or after 1990. And if we were to do a real quick sum, we can see that 8,556 of those titles, so the majority of those titles, do in fact meet that criteria. All right, so let's kind of think through this. So I've got my data. So what we're going to want to do is filter this data frame based off of this release year filter. All right, and what we're trying to answer is what percent of titles are movies versus TV shows. All right, so we have this type column, which is capturing is it a movie or a TV show? So what we want to do is we want to group on that column, and I'm going to assume that this show ID is unique for each one of them. So I'm going to group on type, and I'm going to get the number of unique show IDs. All right, so first let's apply our year filter. So that limits our data to that 8,556 rows. And then we can use pandas to do a group by. And I'm going to say let's group by type. And then I'm going to do a .ag, and I'm going to say unique IDs is equal to, we want to take the values in the show ID column, and I want to get the n unique, so the number of unique values. All right, so if we run this, we see that, okay, we've got, 5,896 are movies, 2,660 are TV shows. What I'm going to do is store this in kind of a temporary object. So I'm going to say, well, this is going to be our show types. All right. And then what I'm going to do is take that unique IDs column. So that right now we've got a pandas data frame, so it's giving us type as the index. So we got movie and TV show. Those are our indices. That's our index for this data frame. And we have one column. I'm going to convert these to essentially proportions. All right, so I'm going to take that single column, unique IDs, and I'm going to override it with the values in that column, dividing by the sum of all the values in that column. All right, so now we have our proportions. So this is our analysis, right? So 68% of those titles are movies, 31% roughly are going to be TV shows. Let's generate some plots for practice. So I'll do fig.ax is going to be plt.subplots. Let's just do 1, 1, and let's say fig size equals 5, 3. All right, I'm going to use pandas plotting abilities. So I'm going to do show types. That's a pandas data frame. So I'm going to do a dot plot. I'm going to say kind. I want to do a bar plot. I want to give those bars a little bit of edge color to make them a little bit more distinct. I do not want a legend. And I want to place this plot on the AX object, or the X object that was given back when we called plt.subplots. Let's just do a plt.show. All right, so now we see, okay, well, these are our, essentially our movies, roughly about 70%, 68%, something like that, our TV shows. Let's make this plot look a little bit better, a little bit more informative. So one thing that I like to do is take that top and right spine. So there's no ticks on those. So those are really just kind of there to show us the border of the plotting region. So they're not really adding anything to our plot. So I'm going to take the right and top, and I'm going to set visible equal to false with a capital F. All right, so that's going to remove those spines. All right, I'm going to rotate these tick labels just a little bit on that horizontal or x-axis. So I'm going to use ax.tick params. That will allow us to control that. If we look at this, you can tell it your axis that you want to operate on. So by default, that's both. We only want to operate on the horizontal or the x-axis. All right, and then here's the things that you can kind of set, right? So we're going to do things like changing the label rotation, and then we might use some of these others in another example. But we want to say the axis is going to equal x, and then we'll do label rotation. Let's just say that that's going to be 30. All right, so that kind of rotates that. I'm going to take that type away. So I'm going to set the X label to an empty string to remove that. And then I'm going to set a title real quick, ax.set title. And I'm going to call this distribution of shows by type. All right, so distribution of shows by type. All right, so that's looking good. The one thing that I'm going to do, the final thing that I'm going to do is change these proportions to a %. And this is where I'm going to use that mticker, right? So if you remember up towards the top, we imported matplotlib.ticker as mticker. So I'm going to use that. And the way that you can, if you've got values that are between 0 and 1, a proportion, or if they're 0 to 100, you can use this as well. You just have to specify. So what I want to do is I want to grab from AX, I want to grab the Y axis, and then I'm going to set major formatter. All right. And if you do mticker dot, it has a % formatter class. And you can specify what's the maximum value that you're going to see along whatever this axis is that you're trying to format those major ticks. So the maximum value we would have, since we kind of formulated it as, or computed it as a proportion, the maximum value would be 1. So I'm going to set the max to 1.0, close that off. And now we've got our percentages. All right, so this answers our first question with pandas. I'm just going to put time up in front. So let's put that cell magic time. All right, so pandas runs this computation on this machine at least in 111 milliseconds. And just so you know, I do have a relatively substantial machine. So right now I've got 8 cores, so it's doing 16 computational threads and a good bit of memory here. So if your times vary a little bit from what I'm seeing, that's of course going to depend on the hardware available on your machine. All right, so now let's go to our polars implementation. All right, so I'm just going to say here, this is going to be our polars implementation. Great. All right, and what I'm going to do actually is I'm going to go up and I'm going to copy what we did with pandas. I'm going to use that kind of as a guide as I'm going along to help me do this. All right, so I'll leave the timing in for now, but I'm just going to go ahead. I've got it copied down, but I'm going to comment it out just so I can see it, but it's not actually running that pandas code. All right, so the first thing that we did is we read in that CSV and we did this filtering. We had to define this year filter here as kind of a Boolean series, and we use that to do our filtering. All right, well, we can kind of change that when we're doing polar. So one thing that you kind of notice is we kind of had to break up our line of execution with polars into different chunks, right? So we first read, then we defined that Boolean series, then we used that and did the group by, and then we did this conversion to a proportion at the very end. Well, a lot of times when we're writing polars, we will kind of just chain things together in kind of a very functional programming style. And that's actually the intended use of polars, because polars actually has query optimizers built in. And what it can do is if you kind of give it all of the code that you're going to run, it can, if you use the lazy evaluation mode, I'll show you kind of how to do that. For most of the case, I'm just going to use eager execution, but you can use a lazy execution mode. And by giving polars all this information about the things that you want to do kind of in this functional format, it can look at the way that you've kind of thought through how you want to perform these operations and kind of do optimizations and can say, oh, well, you shouldn't do it this way. We know based on the research in relational databases, this is the right way to do it. So it will do some optimizations for you under the hood. All right, so let's see how we would do this in Polar. So first off, we'll do a pl.read CSV. So everything looks very similar up to this point. All right, so I'm going to give it our data file path. All right, instead of doing a Boolean filter, so what this actually returns, right? So this returns an object. It returns a polars data frame. So I know this is returning a polars data frame. So I'm immediately at the end of that going to call a filter statement. So filter is a statement that you can apply to a data frame. And since that call right there returned a data frame, I can immediately do that filter. And if I want to say, okay, well, only keep values where that release year is greater than or equal to, 1990, we have to use their expression syntax. And this is what that would look like. So I will say PL call, and I'm going to say release year. So I'm specifying the column that I want to use in this expression. All right, and I'm going to say greater than or equal to 1990. All right, so originally when we read that, it was 8,807 rows. Now when I run this, right, we get back another data frame, but it's correctly filtered to that 8,556. All right, so we've just got one, right now, one command. We're just kind of chaining things out. So we've done our filtering, right? And now we're going to do our group by. Here's one thing to notice, right? So polars, a lot of times in pandas, like when we did pandas here and did that group by expression, it was just one word. Polars is pretty picky about using underscores to essentially separate or add white space so that words are proper. So group by, they're representing that as two words separated by underscores. That's one thing that's going to be, there's a good bit of overlap in the APIs between polars and pandas. However, you do have to realize that a lot of times, even though there might be an equivalent method in pandas, they're probably going to include an underscore if it is multi-words or multiple words kind of concatenated together. So in this case, we've got a group by, and we wanted to group by type. We can do that just like we did in pandas. And then we're going to call a .ag. Again, this looks really similar to pandas. This is going to be the statement that we used in pandas. So when we did ag, we said, well, we want to create a new column, unique IDs, and that's going to be the show ID column and getting the in unique values. This is what that would look like in polars. You need to use that expression syntax. So I'm going to say PL call show ID. All right, so that's grabbing that column, and then I'm going to call a method on that called inUnique. All right, and let me just pull up polars documentation real quick. It's actually really good. Let's just say polars inUnique. All right, if you look over here to the left, so I just went to this particular function, but when you go into polars documentation, they have this data frame section. Right, and it's showing you all of the different things. So if you want, what are the descriptive methods you can use? You can use, is duplicated, in unique, is unique, right? What if we wanted to do, we're doing this group by? Well, we've got these group by things. And then if we look at this expression syntax here, there's a lot of different things that you can do. So if you want to do computation, right? Well, I can get, the mean of an expression. So let's see. So we can do the rolling mean. I actually don't see the mean listed in here. Even though it is defined, they've probably got it in a different category here. I just don't know where to look at the moment. Or maybe I'm just looking right past it. But again, you know, if you think about it, so like this Polars expression, so if I have some expression, some PL call statement, right, well, I can call entropy on that. I can call kurtosis. I can call log. So we can see that you have things for computation. You have things for strings, right? So if you do polars and you've got an expression and that, then you, similar to pandas, if you want to use a string method, you'll do a .str at the end. And then we could do like string extract, string join, and so forth. All right, we'll kind of toggle back and forth to that every now and then, but ultimately I've got an expression right here, and then I'm calling some descriptive method on that. All right, so if we run this, this gives us our data frame that shows, okay, well, what's the count of TV shows versus movies? All right, and then the final thing that we had done here is we divided the values in that unique IDs column by the sum of the values in that column. So if we want to do a computation on a column, we have to use a with columns statement, and then we use expressions. So I'm going to say take the values that are going to be in this unique IDs, which that should now be a column, because again, if you're thinking about execution from top to bottom, right, once we run this ag, we're going to have this column called unique IDs. Well, what I want to do is I want to take that, and just let me double check my sheet over here. That's right. And then I'm going to divide that by everything in that column, another expression, but a sum. All right, so here's our proportions that we saw before, right? And then this is going to be just a little bit different than what is on the notebooks on GitHub. I do this before I plot, but just to kind of show you here. So when we were running the pandas version, let's just look when I run this and I look at that show types object. It's a pandas data frame. We've got a column unique IDs, and we've got an index that's movie and TV show. And using that, we can just do that pandas.plot and make life easy. All right, well, actually, we can immediately convert this to a pandas data frame at this point, right? So now I've got a pandas data frame. Notice I've got an index over here, right? But Polars by default does not use an index, and that's not necessarily a Polars thing. That's the data structure that it's built on. So that's kind of a standard that is defined by, I think, the Arrow project, right? So they don't use row indices like pandas does. So whenever you've got a Polars data frame, like if I were to take that two pandas out, right, there's no index, there's just columns, right? So when I do that conversion to pandas, it gives me an index. So what I want to do to make this essentially equivalent to what I used up here is I've converted it to pandas, and I'm going to do a set index on this type column. So I'm going to set that to be our index. And now this looks equivalent to what we had with pandas. All right. So now I'm just going to call this show types. Great. So that's our code. And then let me copy our plotting code down here. And the interesting thing is, since we used this two pandas and set index to essentially get that object in the exact format that we had when we were using the pandas to do it, the code just runs, right? So it's exactly the same. And I'm just going to do a real quick restart clear all outputs, right? Go up to the top, just read down. All right, so let's look at timing. So when we run the pandas implementation, including the plotting, that's about 125 milliseconds. And then when we do polars, in this case, we got 139. Let me just, I'm not going to do this every time. You can see there's a lot of variability. Let's just run this. Let me take the plotting call out of the first one, and let me do a time it. So it's going to run it many times and get kind of a statistical estimate. So this is going through and doing that analysis. So about 39.4 milliseconds. Let me do the same thing in our polars implementation. Do our time it. And so about 10.8 milliseconds, right? So 39.4 versus 10.8. And this is what you would tend to see. So, you know, in my experience, Polars is anywhere, you know, it's usually as fast or, you know, in many cases, much faster than Pandas. Sometimes that's orders of magnitude, so like a 10x increase in speed. And it also can use a little bit less resources on your machine. So it definitely can be faster, as we're seeing here. And this is a relatively simple analysis. So I'm just going to take that back to time, uncomment my plots. All right. And then we will move to our second question. All right, so let's go get our text for our second question here. So what has been the trend in movie TV show releases by year? All right, so let's say Markdown, and then I'm going to do Q2. All right, so what has been that trend? And then let's go ahead and we'll do our Pandas implementation. All right, so I'm going to do a lot of this, you know, end to end in each one of these cells. So we're going to keep reading in the data. So I'm going to go ahead and copy from our previous Pandas implementation how we did that, reading the data and applying that filter. So data is equal to PD read CSV, that data file path, and then we've got our year filter. All right, so what we're wanting to understand in this one is like, okay, well, what are the trends, right? So have we seen, you know, if we were to think about the number of titles that were released each year, right? Has there been any change in the percentage, the distribution of titles released each year that are movies versus TV shows, right? So let's take a look at that. All right, so I've got this data. We would want to apply that year filter. All right. So we've got our release year right here. All right, we've got show ID and we've got type. So really what we want to know is, okay, well, by release year and type, first off, what we've got to figure out is how many show IDs have we had by type in each release year. So what we're wanting to do is group on type and release year first and count the number of show IDs. So I'm going to do a group by. In this case, we're going to have two things. So I'm going to say release year and then show, in this case, type, sorry. All right, and then we will do an ag, and then we will have our unique IDs. All right, so we want to get this show ID column, and then we'll do in unique. All right, so this returns a Pandas data frame. We have this hierarchical index here, so it includes release year and type, and then we've got unique IDs. What we need to do is we need to pivot essentially. So we want to, I think the way that, you know, makes the most sense is have the release year as the index. And what we want to do is create two columns, one for movie and one for TV show. And then if we think about for a release year and then under a particular column, say movie, we want to have the values here that will represent for this particular release year, for this particular type of title, this is how many releases we had. All right, so the first thing I'm going to do is do a reset index to kind of pop that multi-index back into the data frame as columns, right? So now I've got them in as columns in the data frame and it gave me a new integer index. And then I'm going to use pivot and I'm going to say index because this is a data frame that it returns. So pivot is a data frame method. So I'm going to say, okay, well, since that was a data frame it gave back, I want to pivot that data frame to where the index is the release year. And the columns will be based on values in the type column of that data frame. And I'm just going to say the values, and I would encourage you to explicitly specify the values. If you don't, it ends up giving you back this weird multi-index on the column. So you'll have, like I said, you'll have this tuple for the column labels, which can make working with it a little bit of a pain. let's just look at that actually. This would be a good opportunity. So if I run this, it runs, right? But notice you've got unique IDs and then movie TV show. If I get the columns of that thing, right, notice that my columns are tuples. So unique IDs for movie, unique IDs, TV show. So now if you want to grab a particular column, you've got to do it using that tuple. What happens when you specify the values? Say, well, no, the values are going to be coming from, you know, originally there was a column called unique IDs in that data frame. Now, if we run this, everything looks the same, but we don't have that unique IDs up there. And if we do columns, right, it's just single, right? So not a tuple, right? So it's a string. That'll make working with it a little bit easier, right? All right, so I do believe actually in the notebook, I did not, in the notebook this on GitHub, I didn't use the values, and I included some code to show you how you could go through and get the movie and TV show even in that hierarchical list. And again, that was just to show you if you are dealing with that and you're kind of stuck, how you can grab that. All right, so this looks good. I'm going to call this shows by type and year. Fantastic. All right, so that looks interesting. That looks good. And what I'm going to do now is I'm going to create a series that captures the number of shows in each year, or the number of titles. So 19 plus 3 for 1990, 16 plus 1 for 1991. So I'm just going to say, okay, this is going to be my year sums. And I'm just going to take that data frame and call it dot sum across axis equals 1. So I'm going to sum across, you know, for each row, I'm summing across the columns. All right, so I've got this series. All right, so that was the number of shows or titles in each year. And I'm going to use that to convert each one of those to a proportion. So we've got a movie column. So I'm going to say, well, take whatever the values are in that movie column and divide it by my year sums. And then take whatever is in our, I believe it will be TV show. Let's just look at that real quick. So I'm going to comment that out. Let's look at shows by type and year. So we've got a movie and a capital TV space capital show column. All right, so we'll do TV show. And then there we go. All right, so now we've got those represented as a proportion. All right, so this should be sufficient for us to answer that question, right? So let's get a visualization. So I'm just going to come up here, copy. In this case, it's going to be from our polars implementation. What I'm going to do then, so let me just comment this out real quick, show you the data frame. All right, so if you give this, so in this case, we got a data frame where the release year is in the index, and we've got two different columns, and we want to plot both of these columns. If you give this to pandas, what it'll do is it's going to use the index for your horizontal axis. And in this case, it's going to create two series essentially of Y values or vertical axis values, one for the movie column and one for TV show, which is exactly the behavior that we want. So that's going to be perfect. We're going to do this with a line plot. All right, so we're going to say shows by type and year. We're going to change that to a line plot. Line plots do not have an edge color argument. All right, and we'll go ahead and give ourselves a legend since we're going to have two things that we're plotting. I'm going to take those spines off. Let's just keep that X rotated. I'm going to keep that X label off. And then let's say we're going to keep our formatter in there because we converted this to a proportion again. And I'm going to say number or percent of shows or titles by type. All right, So this is what we see. So we can see that there has in fact been some type of a trend, right? So we're looking at data from 1990, and in this case, it seems to have cut off maybe in 2021, something like that. But we have seen that over time, at least the titles that are being represented or released or available on Netflix, we tend to see, you know, a move away from primarily movies. And then here in that last little bit, right, there was a sharp movement towards TV shows being kind of the dominant. So in that last year there, we can actually see that TV shows overtook movies as being the title type that had the highest degree of representation on that platform. Now, again, I don't know if the data was censored, right? So again, I just got this data set from Netflix. So again, this might not be the whole story, but that's how we would conduct this analysis using pandas. All right, so now let's do our polars implementation. All right, so 1, 2, 3, 4. We'll do polars implementation. And like we did before, I'm going to copy down what we had with pandas. All right. All right. So what we had done is I'm just going to go ahead. Our final object was called shows by type and year. Oh, and let me put time up here. Let me go ahead and time this pandas implementation, even though, again, as we saw, time it is really what's going to give us the most accurate representation. So that took 111 milliseconds. All right, so let's say shows by type and year, and I'm going to do a pl.read CSV. That's going to be from our data file path that was defined earlier. And then we're going to do that filter where pl call release year is greater than or equal to 1990. Right? And then what we wanted to do, we did a group by. So I'm actually just going to copy that group by statement, uncomment those. All right, so we do a group by in polars. It does group by separated with an underscore. All right, release year and type, and we'll do an aggregation. We're going to create a new column called unique IDs. We have to use the expression syntax here. So pl call show ID, and instead of in unique all is one word, again it's in underscore unique. All right, that's good. And then we had to do a reset index with pandas because when group by, it puts the grouped the columns you're grouping on as new index, but we don't have an index with polars. So again, if we were to see this now, right, it's just a data frame. Polars data frame, there's no index. All right, so we can immediately call that pivot. All right, you have to give it an index, which we said would be release year. In polars, at least as of the 1.0 release, when you're doing a pivot, you don't have a columns argument, you have an on argument. So that's going to be the same thing as columns. So we're going to pivot on the type. And they do that to be consistent with another method that they have called unpivot, which essentially does the reverse of a pivot. And then we can specify our values to be that unique IDs. Great. All right, so if we were going to look at this right now, again, all right, so we've got our pivoted series. Notice that polars has not sorted that release year. So polars will do computations in its group by. Whenever you call group by, it does that in essentially a multi-core or concurrent fashion. And as a result, it can't guarantee that it's going to be sorted, right? So if you wanted to sort by release year, you definitely could. We will probably go ahead and do that in a minute. But for now, what we want to do is take each one of these rows and say, okay, well, we've got in 2020, we had 517 movies, 436 shows. We want to sum those up and divide each one of those values by it. All right. And this is one that looks a little bit interesting, right? So if you think about it right now, we've got this polars data frame, and we've got two columns in here that we want to sum up. But what if we had 100, right? You might not want to go through and hard code all of those, right? But you can't just say sum across everything because we got this release year thing, and that's numeric, right? So you don't want to add 2020 to 517 and 436, right? That's going to skew things. So, you know, giving you, larger values as your years are increasing. So you only want to sum the movie and TV shows. And again, what if you had 100 other columns that were things you wanted to sum, but you just didn't want to sum release year? So maybe, they had things like documentaries or whatnot. So all the categories. So what we want to do is say Polar sum everything except for release year. All right, well, how do we do that? So what we need to do is we will do a with columns. So we need to do a computation. And what we're going to do is say, we'll take all. So this is going to be our expression. Usually we would do like a PL call and give it a column name. Well, in this case, we're going to say do all of the columns except for, so exclude, and then we'll say release year. All right, I'm passing it in as a list. I think in this case, since it's a single value, you could just pass in that string. All right, so this is going to give me all the values in all the columns except for release year. So I want to take the values in each one of those columns, and I want to divide it by the sum across all of those columns horizontally, so across the columns for each row, right? So I want to sum 517, 436, 658, 244, right? So I'm wanting to kind of just sum that horizontally across the columns for a particular row. And the way that you do that is Polars has this pl.sum horizontal, and you need to tell it the columns that you want to sum. Well, we want to sum everything except for release year. So we just copy that same expression right there. All right, that should be good. Let's just take a look. All right, so now we've got those converted to proportions, right? And we can see that if we were to sum each one of those up, that is going to sum up to essentially 1. And now we'll do that sort. So I'm going to sort by release year. All right, so we should be good. So let's just take a quick look at the data frame. Yep, that looks reasonable. And we are going out to 2021. So I'm going to do the same trick. I'll do 2 pandas. And then I'm going to set the index to be release year. All right, that looks great. All right, so we've converted that code to Polars. Let me just pop our time at the beginning. And then I'm going to copy our plotting code. All right. And there we go. So we see exactly the same result that we saw previously. So again, I'm just going to run the pandas implementation, Polars implementation. So again, we do see, even though this is just kind of a one-off run, 95 milliseconds versus 119. Of course, if we went and did the time it, we would see more dramatic results. Let's just do that one more time. We won't do this for the other examples, or actually let's hold off to the other examples because they're a little bit more involved. So we might see more significant speed ups later on. All right, so that answers question 2. All right, so now we are going to go and we are going to look at question 3. All right, so if we go to the top, question 3 was, who are the 5 cast members associated with the most unique titles? So again, when I asked this question, maybe I could have phrased that a little bit more clearly. But what I'm essentially looking for are, which cast members have been on, right, or participate in the largest number of unique categories. All right, so let's do our pandas implementation. So I will say pandas implementation. All right. And this is going to be a little bit not too involved. We'll see something that we, haven't seen before, or at least in this notebook we haven't. Let's go back to where we got pandas code. Let's go ahead and copy in that first little bit where we're doing that filtering. All right, so I've got the time, I'm reading that data, and then I'm getting that Boolean series at least. All right, so what I'm going to do is I'm just going to go ahead and take my data and override it based on that filter. All right, so let's look at this. All right, so what we want to know is, okay, well, for these individuals, right? So if we were to get all of the unique individuals out of this cast column, which individuals are associated with the highest number of unique show IDs? All right, so this is a little bit odd, right? So remember, they put the cast into essentially this is a string. So they've got all the cast members in a string that's just, uses commas to separate. So what we need to do is take these string values, split them on those commas, make sure that there's no trailing or leading white space, and then we can start to do those analyses. So we got to split them. And then really what we need to do, like in this example that is highlighted, so we've got at least 1, 2, 3, 4 individuals. What we need to do is figure out, okay, well, I need to get each one of those individuals on their own row associated with that show ID. So I need to have, this first individual with S2, second individual with S2, and then we can just use group bys to make work of this. All right, so the first thing, let's work on that cast column. So I'm going to say, okay, well, give me back cast. All right, if these are strings, I can see that this is an object type. So I need to use that string accessor method available in pandas, and I can split that based on commas. Oops. All right, so now we have a list of all of those individuals that had a comma. And again, I'm just assuming that, that's how they're doing it. I do believe that is exactly correct. So I don't think anybody's got a comma in their name. So, all right, so what I'm going to do is I'm going to overwrite the values in that column. And then, so now we've got essentially a list of individuals, and I need to know, well, this first individual, associate them with S2. Second individual, associate them with the S3. So what I'm going to do is I'm going to say, well, okay, let's explode the data based on this column. So if you have a list in a column with different values and you call explode on that column, it essentially will repeat those rows for every entry in that list in the column. So we'll repeat the row S2 for every individual in that list. All right, so when we do this, right, we notice we originally had like 8,807 rows. Now we got 62,953 because we've exploded that, right? So now if we look for show 2, right, we've got 1 row for each individual. And that's what we're going to need for this analysis. All right, and what we also want to do, because if I were to look at this, right, so this was the first individual in that cast list, but so let's grab this one right here. So I'm just going to say, let's do alloc and give me back the second row. All right, and I want to grab that individual. So I could just write this thing real quick to a dictionary. Let's look. Yeah, here's what I wanted to show you. When we did that split, since we split on the commas, well, it was technically a comma and a space. So for everybody except for the first person in that list, they're going to have an extra bit of white space. Well, that's going to be a problem because we're trying to figure out how many times are these cast members represented, right? So if in some rows they don't have a white space before their name and in some they do, well, the computer's going to think that those are 2 different individuals. Those are 2 different strings. So it's going to count them as being different. Right now, we could, of course, just when we do the string split that on comma space, right? But again, I'm going to show you with, let's say that you had this situation. I wanted to show you to make sure that you understand how that problem can arise. And I'm just going to keep it with the comma. And then what we would do is take the values that come back. So now I have to take the new values in that cast column and do a string.strip. All right, so that should be stripping that white space. And then we can go through and do our normal type of group by aggregation. So topcast by IDs. I'm just going to say data dot group by, and we will in this case be grouping by values in that cast column. And we're going to aggregate. I'm going to say unique shows. So I'm going to get that show ID column. Do the in unique. All right. And then let's just look at this. So we got top cast by IDs. All right. So we only want the top 5 cast members. So we've got now cast and then unique shows. So I'm just going to say get the in largest. So that method. And you tell pandas, well, what's in? So in this case, we'll say in. Let's be explicit. N is equal to 5. And then what columns do we want to, get the in top from? So I want to base that on unique shows. So I'm going to say columns equals unique shows. And then we'll put that down. All right. So we're making that assignment. That's a pandas data frame. I'm just calling in largest on that data frame. So I could just chain that right to the end. And now we've got our top cast by IDs. Fantastic. All right. So what I am going to do at this point is let's go back to the very, very top. Our first question, we did a bar plot. I'm going to copy that code for our bar plot because this one we have individuals. So this is like categorical, right? These are strings. All right. So I'm going to say topcast IDs, topcast by IDs dot plot bar. We'll do edge color K, no legend. And I'm just going to say number of shows. Cast. Let's not, we don't have to format. We're not dealing with percentages anymore. So there we go. All right, so that's for the top 5. What's the number of shows that they were in? All right. So that is our pandas implementation. So I'll run that one more time. So again, we got a lot of uncertainty, about 164 milliseconds seems to be kind of where it's at. All right, let's do this in polars. So we'll do our polars implementation. Great. All right, so I'm going to copy our code down from pandas. All right, we'll put that down below here. All right, so we're going to say data is equal to, and we're going to do this in a chained fashion. So instead of doing data, I'm going to say topcast by IDs. We're going to go ahead and create that object and see if we can do all of this, because in pandas we had to do quite a bit. So here's one line of code, then we did another computation, another one here, 1, 2, 3. So we did a lot of independent little blocks. All right, so I'm going to do a pl.read CSV data file path. And then we could do, I'm going to keep it as it is, right? So it was a little bit different in the notebook when I did in the notebook that's posted online. I believe actually in both cases, so both for pandas and for polars, I had shown, because this explode, when we were doing that explode, and remember we created those extra rows for each value in that list for that column, for that cast. So that recreates a lot of data. So we went from like 8,807 entries to like 60 something thousand. So to save memory, since I know what columns I'm going to be working from, when I did that read CSV, I just said, you know what, only bring in the columns that I know I'm going to need. That way, when I did that explode and created all of those duplicates, it wasn't as much duplicate data. So I will show you how to do that. So here's that pandas implementation. Let's just make that change. So if we go to pd.readcsv, hold down Shift and Tab, we have a use calls argument. All right. And if we think about what columns did we actually use when we performed this, well, we needed release year, we needed the cast column, and then we did the show ID column. All right. So previously it was taking about 194 milliseconds. If I run this, right, a little bit quicker there, but again, we need to run it a few times, but it should be just a little bit quicker, definitely a little bit more memory efficient, because when we first bring in that data, we're only bringing in the columns that we need. All right, so how will we do that I'm actually going to copy those columns that we need and show you how we would do that with polars. So when we do a pl.readcsv, it's got a columns argument. So instead of use calls, it has columns. And there we go. So that's only going to bring in those 3 columns. Now, one thing to note here is that we've got some missing values. Now, when we looked at pandas here, we didn't see any missing values here. And this is going to show a very, subtle difference in polars and pandas once we do this analysis. All right, so good. So we've got in the data we need. We need to do our dot filter, use our expression. So PL call where release year column is greater than or equal to 1990. All right, so that takes care of that bit there. I'm just going to get that out of the way. And then let's mimic this thing here. So we need to do a computation on a column. So we do that with columns. All right, we need to take the cast column. So this is an expression. We want to do a string expression. So if I went over to polars documentation, and if I'm looking in their expressions area, if you go down to string, you notice you can give it a string. So it says polars.expr, so polars expression.str. And then you can do, again, a dot split like we did with pandas, or a dot, instead of strip, it has strip cars, so strip characters. All right. So what we want to do is we're going to do a string dot split, just like we did in pandas. All right. That's going to return, at this point, we've got still a polars data frame. Notice that that's now a list. When we did that split, see, you can see that white space in there and those second cast member names. All right, now we want to do an explode, which works exactly the same way as it did in pandas. So I'm calling this on the data frame, right? It's not in a with column, so I'm calling this on the data frame itself. That last with columns return to data frame. So now I'm going to explode on cast. All right, so now we've got that long 62,953 entry data frame. All right, and then what I'm going to do is, again, take a with columns, take that cast, and then I'm going to do a strip cars. Great. So that's looking good. We don't have weird white space at the beginning of cast members' names, so that takes care of this piece. And now we've just got our group by. So I'm going to uncomment, delete that up. So in polars, group by, separated with an underscore, so we're going to group on cast. Aggregate unique shows is equal to PL call show ID dot in unique. All right. All right, so this is doing that. So now we're down to 35,000. And in polars, instead of in largest, what you actually have is you've got a top K. So I'm going to say polars top K. Here's the documentation that is defined on a data frame. So if you have a Polars data frame, it has a top K method. You need to specify K, and there is a by argument that specifies the column that you're going to use to determine the top. All right, so we'll do a top K. We specify K is equal to 5, and then we say by is equal to, in this case, unique shows. All right, so here's a subtle difference, right? So if you look here, notice that it's a different result than we have with pandas. So when we look at the cast, Polar says, hey, you know what? The missing, right? So null actually is the highest. So we see null as specified as cast for 811 shows. Pandas just ignores it, right? And that's kind of a subtle thing, and that's one thing that Polars was, really wanted to make sure, null is a first-class thing, but we need to be cognizant of the data missing, right? Because, that the fact that 811 out of these 8,000, so more than, roughly 10%, it's actually a little bit less than 10% because we got like 8,800, but a little bit less than 10% are missing, right? So you need to be aware of that. So Polars presents you with that so that you're aware, and you have to tell it exactly what you want to do to get rid of that. All right. So in this case, it at least presents it, and we say, oh, well, gosh, we've got 811 missing values. Maybe we need to investigate why that data is not there. In our case, what we're going to do is we're just going to drop those. So right before I do that top K, I'm going to say drop nulls. And in particular, I want to drop them in the cast column. All right, and if we take a quick look at this, right, so that should be pretty much exactly what we've seen previously. And it is. So I'm going to do two pandas. And then I'm going to say set index cast. Fantastic. So now I can copy my plot or my plotting code. And there we go. There's our analysis. All right. So let's do a time. Beginning of that. So 87.2 milliseconds versus 134. So we'll just run them both. One more good fresh time. So this time it took Polars 229 versus 85. So this is a little bit more involved example because of that explosion. So I am actually going to comment out the plotting and do this with a time it. So here's pandas results. Take it just a second. All right, so 65.3 milliseconds. And then let's do this for Polars. So let me take away the plotting. So we had 65.3 milliseconds for pandas. And let's see what we get for Polars. So 17.1, right? And it ran 7 runs of 100 loops, right? So it basically ran 700 trials. So 17.1 versus 65.3. So you're roughly looking at around a 4x speed up because of using Polars. All right, so let me change that back to time. Otherwise, it's going to generate a ton of plots. And there we go. Awesome. And at this point, we are going to be on to our final question. So let me just jot down the time so that I can do the chapter markers. All right, so now let's go on to our final question. So I'm scrolling up here to the top, and it's Q4. Let me copy that back down for us. All right. All right, so who are the 5 cast members associated with the most unique categories. So again, like we did here, I probably could have worded that better. But you know, essentially want to figure out, well, which cast members have been in titles that are associated with the largest number of unique categories. All right, so we will do our pandas implementation. Make that a little bolder. There we go. All right, so I'm going to go to our previous pandas code, copy down some things because we're going to be able to leverage this, I do believe. All right, so in this case, let's just read in, first off, I'm going to take away that use call. So just commenting that out, commenting everything else below. So I'm just going to read in that data and do a data.head because we need one column we haven't used up to this point, and that is this listed in. So this is our categories. Again, if something has associated with multiple categories, they've just created a string that's separated with commas. So we're going to have to essentially do the same trick that we did on the cast to this listed in column. But we do need to bring in listed in. All right. Then we'll do our year filter, all of that. All right, so we got our year filter. We're going to need to do what we did for cast, and we're going to need to do the same thing for our listed in column. So we're going to end up with a very big data frame because we're doing this explosion twice. All right, so first we're exploding on cast, stripping any white space. Then we explode on listed in. All right, so if I were to do data.shape, now we've got, you know, fairly big data, right? So 144,000 rows, right? And if we look at this, right, we're going to have potentially, like in this case for S2, well, this was your first cast member, and that show S2 is associated with international TV shows, TV dramas, and TV mysteries, right? So we've kind of got all of these combinations. So things have really, you know, exploded. For lack of better terms, from 8,800 rows to 144,000, right? But once we get the data in this format, it's pretty straightforward. I can actually go up here and pretty much copy most of my pandas code. All right. So instead of it being top cast by IDs, we'll say top cast by categories. So we got cast. And instead of, you know, working off of the show ID, we're going to work off of the values in that listed in column. And we'll call that our unique categories. All right, and then we want the n largest based on unique categories. And then what we want to plot is top cast by categories. And then we'll say number of categories by cast. Let's see if that's working. All right, so that looks relatively good. So Ron Perlman, Gary Cole, and some others, Antonio Banderas. All right, let's get that timed real quick. So 330 milliseconds. You know, I guess I'm sure if we run this a couple of times, well, staying around 340. So because of those two explodes, you know, that does tend to be a costly operation. All right, let's look at polars. So we'll do our polars implementation. There we go. And like we did with our pandas implementation, I'm going to go copy what we did for polars because this is going to be really similar. All right, so we're going to change this to top cast from by IDs. We'll do to categories. So top cast by categories. We need to bring in that listed in column. All right. Here's the columns doing all of our explosion piece. So we're doing that for cast. I'm going to copy them. And we're going to do it one more time for listed in. So here's doing the split. Here's the explode. And here is the strip. And then instead of unique shows, we want to do unique categories. All right. Categories will be enlisted in that exploded column. We're getting the number of unique. We're dropping nulls. We don't need to do that drop nulls. We were doing that because some of the cast members were null. We don't know if that's going to be the case here. So let's just drop it for now. And actually, let me take all that to pandas stuff and our plot, comment that out. Let's just take a look at what this data frame looks like. All right, so let's see. I converted this to unique categories, and I'm still doing top K by unique shows, so that's got to change. So top cast by categories. Let's take a look here. All right, so let's see. So let's take a look up at Pandas. So that does seem to be correct. We do apparently have some, yeah, we are going to have to do that, right? Because that cast, that's where our null values are occurring. So we do, in fact, need to do our drop nulls. Don't know what I was thinking. Long video. There we go. All right, so Ron Perlman, Gary Coleman, Kieran and Chipka. And then we've got some differences right here, but what I noticed is actually there's a lot of people that have 14 categories. So when we're doing this top, it's just returning, you know, the 2 that it found first. So if I were to expand that out, actually there's a lot of people, right? So you can see that, yeah, it's really, and one thing about Polars is it's going to be a little bit random, right? It's doing some of this in, you know, multi-cores. So you know, the exact order that you get that back. Now, if you wanted to return all of them that achieve something, that'd be a little bit of a different coding problem, but that's what's going on. So it looks like it's behaving. So top 5. So we definitely do have at least consistency on Ron Perlman, Kieran and Chipka, and Gary Cole. And then we'll get random variation in the 14s. All right, so that looks good. So we'll do a toPandas set index cast and then PLT show. All right, so first off, we need to change this to top cast by categories. And let me make sure that I had done that up there. I had. All right, so we've got top cast by categories, and there we go. All right, so changing what we call dot plot on. All right, so let's comment out our plots because this is our most involved question, or the most, you know, this question was the most involved to answer. So let's do a time it on pandas, and then we'll do a time it on polars. So 145 milliseconds there on pandas, and now running the polars implementation, 27. So 27 to 145. So, you know, significant speed ups. Now, one thing I did want to show you is that, so let's kind of go back. Sometimes we can get even more significant speed ups. Because one thing, I mentioned this at the beginning of the video, I know that's been quite some time ago, but, you know, so what we've done using pandas right here is we've done everything in eager mode. And you might say, well, gosh, what is eager mode? There is a mode that you can operate with in polars that is lazy execution. So right now we've kind of been laying things out, and polars is still doing its optimizations, but if we do things in lazy mode instead of this eager mode, I believe that polars can do even more substantial optimizations. All right, so let's go back. I just did a restart kernel and clear all outputs. So let's look at question 1 and let's see how that would work. So with pandas, right, took about 125. Let's comment out that plot, and let's change that to a time it. So this is for question 1. Pretty simple question. We did the filter, did a group by, and just converted to some proportions. That took 39 milliseconds. Let's look at polars. So if I do time it, some 9 milliseconds, right? So roughly in this case, 39 to 9. So, almost a 4x speed up. I think this one actually is more than a 4x speed up. All right, so this is eager execution mode. Now, what you can do, so, we're kind of, if you think about it, we're kind of writing out like a list of like, do these things. So read the CSV, filter it, group by, aggregate, take these columns, convert to pandas, and so forth. What you can do is you can say, okay, well, I can, and this mode is, kind of Polars is kind of stepping through it. It is doing optimizations along the way, but we're not getting, I believe, the full benefit. So if we want to tell Polars, hey, this is what we think you should do, but you have full reign to kind of figure out if there's a better way. Instead of doing a PL read, if you notice when I do a PL dot, I've got a lot of read methods like we do in pandas as well, read Excel, read Delta, read Parquet, but we also have a lot of methods that start with scan. So we can scan a CSV, we can scan a Parquet, and it's not as extensive. There's only certain files that you can scan, but you can do a scan, and let's just look at the doc string, right? And it says lazily read from a CSV or multiple files via a glob pattern. So this allows the query optimizer to push down predicates and projections to the scan level, therefore potentially reducing memory overhead. So the interesting thing is if you call like PL scan CSV on our data file path, right, it doesn't actually do it. You can see it's instantaneous, right? But it says, hey, well, here's the plan of what I think I'm going to do. Right? And what if we did all of this group by and aggregation right there at the end of it? All right, so it's giving us back a plan, okay? And then you can actually, do some type of optimize. So let's actually see what this looks like. It says, well, here's a naive plan of what we think we'll do. If you want to see the optimized plan, run this. So let me save this as temp. All right. And then it was, let's see, I have to run that. I've got to see what that command was again. So lazyframe.explain, optimized equals true. So we're going to say temp, and we'll do temp.explain, optimized equals true. And we can print that. All right, so this is showing you, hey, this is what Polars is going to be doing under the hood, right? So it's doing some type of selection and doing these things, and it's recognizing, notice it says, hey, even though you didn't tell me that you're only going to use 3 columns like we did later on when we said, PL read CSV, and we said, columns equals, it's actually figured that out and said, hey, you're only using 3 of 12. So I'm going to take that into account when I do this loading, and I'm not going to fool with them. Right? So we can do the scan CSV. The thing is, though, like we just saw, it actually doesn't return anything. It returns a plan. So how do we tell it to execute the plan? Well, you do change the read to a scan. All right. And then what you need to do, and I'm going to do this right before that call to pandas, you can say .collect. So what it will be doing is it will take everything between the scan CSV all the way up to this collect, and it's going to optimize that piece. So there's certain pieces that can't be done in that optimizer, and it will tell you if you've got that wrong. So I don't think it can go to pandas, and definitely once we've got it to pandas, it can't set an index because that's pandas, and pandas only has eager execution. All right. So previously when we ran this, we were 9.4 milliseconds. Now if we do this lazily, so letting Polars really do its optimization, we get a further reduction to 5.19 milliseconds. So in the most, in this case, this is, the highest degree of optimization. So with pandas, we were at 39 milliseconds, and then we got it all the way down to 519. Right. So if we think about it, so 519 divided by 39 roughly. So it's only taking 13% of the time with this lazy execution in Polars that it took with pandas. All right. So I'm just going to leave this one for right now, take that timing out. And I do want to show you one last little example of that lazy execution. All right, so let's go all the way down to our last cell. So here's our pandas, and then here's our, I must have time it in there. There we go. Let me take that out. There we go. All right, so here's our original polars. Now you might say, well, gosh, well, can we? How much can we speed this one up? So let's test it real quick. So let's take that plot out. Let me do time it here. And then we will do the same thing for polars. And we'll do a time it. So 151 versus 26.8. So it's already pretty fast. So 26.8 divided by, it was 151. So it's only 17% of the runtime. Now watch what happens. So what we had done to change this to eager execution, or to lazy execution, I'm sorry, we could do a scan CSV. And I said, well, I'm going to go down right before two pandas and do a dot collect. All right. It's going to give me an error, right? And this is, you know, what I was talking about with everything, you know, oh, so this is actually a different error. So when we do a scan CSV, we don't provide it columns. Sorry. So let's go and take our columns out. It'll figure that out. All right, so it actually did, right? So this must be something kind of new in the 1.0. So, and I'm sure there's going to still be some cases. There's some things that can't be run in a lazy fashion. It tends to be like explode. I don't think is. I think it ends up kind of pulling all of that back. But you know, so you can see when we had, you know, just the eager execution, it was 26.8. Well, we got 27 here, right? They're probably not statistically, the difference isn't probably, you know, statistically significant, but we didn't really get that speed up there, right? That we would have expected to see. So, you know, you can use it, but there are going to be certain operations that, you know, just make it where it's not going to be as much benefit. Last thing I'm going to show is just to show you kind of what's, you know, one of the big benefits here. Hopefully we will see this. So I'm going to run this time it with that read CSV, and I'm going to pull up my system monitor here. So I've got my core usage at the top. So this is going to be my CPU usage. And then at the bottom, that's going to be memory. So I'm going to run that and try to get back to that pretty quickly. So you notice we've got, you know, that core usage goes up. Again, this is not a horribly complex or large data set, but notice that when we hit that, right, we saw, you know, kind of an increase in the usage of our CPU cores versus when we do the same thing with pandas. This is kind of, we do see a little bit of movement, but it's kind of flat, right? So one thing that Polars definitely has put a lot of emphasis on is better usage of your hardware, right? So if you're working with really big data and you've got a lot of memory, a lot of CPU, you know, Polars really has some methods in some of those optimizations, really kind of, you know, sharing work among your various cores on your machine. All right, so that was a relatively long video. Hopefully that was, you know, started to give you an idea of, okay, well, if I've got pandas code, what does it look like as I start to do this translation, or I'm interested in doing this translation to Polars. Again, there's a few just kind of syntactical things that are, you know, going to be different. Like, you know, Polars is always going to, like the read CSV, which that's the same in pandas and Polars, but whenever we're doing like group by or drop nulls, right, we're using those underscores. We're separating words, right, instead of just jamming them together. And then this kind of functional way. So if you can get your code where you're kind of defining almost like a pipeline from beginning to end, reading that data in, and then working with these various transformations or whatever you're doing to your data, all in this functional way. That's kind of how Polars is designed to be written, because it kind of then if you're using that lazy execution or just the optimizers and polars, it can really see the full context of your code and understand how to make those optimizations. All right, so that is going to be the end of this video. The clean notebooks are, of course, on GitHub. And we will see you next time in another end-to-end comparison.